Hello everyone, this is Sohail once again with the new video, and this video is regarding, or its video is all about the Ggbs, like the replacement of the Ggbs in the cement and concrete mortars, the replacement of Ggbs at what percentage, how and what parameter it influences, and the what property it enhances, and what makes it to replace the Ggbs up to the maximum percentage and the most desirable economical condition with the properties that what you desire on the site, so that you can work easily. So we all know that Ggbs is the chief supplementary cementing material. The chief supplementing cementing material. I called it chief because nothing can be replaced in the world compared to the volume or by a percentage to a cement equals to the Ggbs, as there are some international documents which supports the replacement of Ggbs, like Indian Standard Code IS 455, which is the specification of the slag cement, which supports the replacement of Ggbs up to 25 to 70%, and ACI 211, which is the standard practice for the selectioning of proportioning for a normal or heavyweight and a mass concrete, which supports up to 25 to 70% of the replacement of the Ggbs, and the ACI 31811, which is the standard practice code for the structural concrete, which also supports up to 70% replacement of the Ggbs, and the ASTM C989, which is the standard specification of Ggbs for using in concrete and in mortar, which also supports up to 65% replacement of the Ggbs. And then finally the BSEN 197/1 2011, which is the composition, specification and conformity criteria for the common cement, which supports the replacement of Ggbs 36 to 65%. Okay, so more or less the replacement of Ggbs is up to 70%, is have a provision in a code, in an international code, that you can replace in the concrete. Okay, so now the question is how. The question is what parameters influences the replacement of the Ggbs. The question is what actually enhances the property in a practical life, in a commercial way. So before that, we must know Ggbs have a glassy and crystalline structure, as the BS 6699 and Indian Standard Code 12089 confirms the material, which is called Ggbs, and how it extracts, what's the process it involves, you all know, and there are a lot of videos available on YouTube, so you can go through it. But this video is mainly about what influences the replacement of the Ggbs in a concrete, general concrete or commercial concrete. So how to overcome this? So the glassy face consists of alumina silicates of calcium, which is mainly responsible of hydraulic properties, the cementitious properties of Ggbs, which exhibits the cementitious property because of this. The glassy face, which consists of alumina silicates of calcium. So to activate that alumina silicate of calcium, we required the alkalis, the alkali activators, in the form of calcium or in the form of silicates, additional silicates. So which can be provided in the form of OPC, or you can provide it additionally. So that's why I told the 100% replacement is not possible in a general way, until and unless you won't allow the supplementary, the activators of the alkali which are present in the Ggbs. So if we replace the high volume of the Ggbs in day-to-day life in the commercial way, then what consequences, what issues we face? Generally we face the issues, the slow setting, the slow strength development, the slow rate of hydration, which causes lot of effect. So the first issue what we face is slow setting. The Ggbs is composed of C3S, C2S, CS, and also in some different mineralogical form, it also having tricalcium aluminoferrate and tetracalcium aluminosilicate, or a dicalcium aluminosilicate also. So more or less it is almost the cement, okay, but the whatever alumina, whatever the calcium, whatever the silica, whatever the iron compound present in the Ggbs makes the Ggbs is less reactive because the unavailability of alkali activators. That's why we add the cement. So to overcome this issue, we have to provide the calcium hydroxide and the addition sulfates, which we are providing through the hydraulic cement OPC 53 grade generally. But we also have to counter the strength development, not only the setting, the fast setting, the strength development also. So for the strength development, every cement is having or contains C3A for to enhance its property of setting time. But when we are going with the combination of Ggbs, especially in a high volume, the C3A is consumed by the Ggbs. Then the combination of Ggbs and the OPC 53 cement, whatever you are taking, it turns to, or it provides, or it enhances the property of sulfate resisting concrete, the resisting of sulfates, whatever present in the weather or in an environment, okay. But at the same time, when it is consuming the C3 of the cement, it reduces the setting time, it makes the setting slow, okay. To overcome this, what we have to do? The first question that we have selected is the setting time, or the why it is slow and how to enhance it, how to improve it. So at the time of selecting of OPC 53, whatever the OPC 53 or 43, whatever you replace, select the cement which is having a C3A content more or less, not less, more than 10%. More than 10%, like 11, 12, 13 is good. Okay, the whatever the C3A combination they are taking to for the setting time of cement is regulated with the help of gypsum. Okay, so no doubt in that. So but it is good to have more than 10% or equal to 10% of C3A when you are going for the high volume of Ggbs. The second criteria, okay, you will not get in the market like what you expecting to do, but you will get the second option like C3S, which is also present in the cement, which also enhance the setting time and the strength gaining properties of the cement, hydraulic cement, or the OPC 53 or 43 grade of cement. So what at the time of high replacement of the Ggbs, you have to select the cement which is having the share, the percentage of C3S in it should be more than, must and should more than 45%. If it is good, 50 and 55%, okay, then we can go. See, the concrete and the setting, the cement, both are different. The setting time of the cement is only enhanced by the Ggbs, only can reduce or regulate by the gypsum, okay. But when you are going to the concrete, you have the admixture in addition to that, which are composed of accelerators, so that the setting time can be manipulated, so the setting time can be adjusted in a concrete. Okay, so now coming to the point, we came to know that to regulate, to enhance the setting time, the required whatever with the high volume of the Ggbs is, we have to select the cement with the 45%, more than 45, 50, 55% of C3S and more than 10 or equal to 10% of C3A. So next, coming to the point for the strength development, early strength development. So for the early strength development, we have to understand the phenomena, the formation of crystalline formation of the standard paste, what we call the most stable paste, calcium hydroxide paste, how it forms. We have to understand the phenomena. So in this, what happens is, at the time of hydration, cement produces the calcium hydroxide, but it also consumes the calcium hydroxide. It also consumes the calcium hydroxide. When you are adding the Ggbs in the same process, making the paste of calcium hydroxide, what we call the stable paste, when you are adding the Ggbs in that, the size of crystals will reduce. So whatever the calcium hydroxide crystal produces in that process, the Ggbs combination will make the reaction is more faster, so that the production will be not sufficient, so that the strength will get faster, to get developed faster. What I want to say is, when we are adding the Ggbs, the consumption is more than the production. So to increase that production of calcium hydroxide crystals, we have to supply, or we have to provide the calcium oxide. The what we call the lime content, because when the standard paste of, if we take generally the hydraulic cement, whatever the standard paste produces, it is having very less amount of free lime, so that the crystalline formation is very fast. So the setting gain is, the strength gaining is very fast along with the setting. So setting we came over through what it makes, what it enhances. Now the strength part. For the strength part, you have to supply the calcium, you have to supply the calcium compounds, or we can say generally the calcium oxide we have to supply. But at the time of supply, we also faces the issue from where, from how we can supply the calcium oxide. So it's very simple. Either you have to select the cement which is having the rich content of calcium oxide, whatever the ratio it is, more than 65-70% of up to, or the high reactive calcium. Or second option, you can provide the rich pozzolana material like C types of fly ash, which is having high percentage of reactive calcium in that, so that by adding the pozzolana up to 10 or 15%, which is negligible in 1 m³ of concrete, so you can go with the early strength gaining property. We can provide the early strength gaining property, and also by adding the calcium through the C type of fly ash, you can make the concrete most economical and the most durable also, because you are having the Ggbs, fly ash and the OPC formation. So now coming to the point. So what actually the point we discussed is how to overcome through the slow setting, and how to overcome through the early strength gaining of that with the high volume of Ggbs. So now coming to the point, the best Ggbs, whatever the available in the market, without knowing this all data, whatever the video we have conducted or done, whatever the explanation I have given, the percentage, the chemical composition, okay, everything, there is one called basicity, which is expressed in the form of K, okay. And in any Ggbs you will take the test certificate, they mention that Kb value, okay. The basicity is in three forms: acidity, acidic, neutral and basic, okay. So whatever the Ggbs we select, it is better to go with the neutral or basicity. Like the neutral value is having around 0.9 to 1.1, but the basicity Ggbs is having around 1.1, more than 1.1. It's good for the practice. So in this video, the conclusion is that you can overcome with the slow setting, you can overcome with the early strength gain issues of the Ggbs, high volume Ggbs, and you can design the concrete with up to replacement of 70%, but on only one condition, that you must have to conduct the trials, not only one, multiple trials with the multiple combination, then have to get the conclusion. The concrete technology is nothing but the observation, the trial and error. So guys, I hope you found this video as an informative, knowledgeable. So I hope that you people will support me like you have supported. Please like, share and subscribe my this video and the channel. Thank you very much.